All right, so this video is going to go over pages 20 through 24 in your Kinematics 2 packet. So we're going to take a deeper look into the 5 kinematic equations. Okay, so first of all, we will give you these equations. Okay, so one thing you need to look at is this missing variable right here. Okay, so whenever we give you a problem, we're going to basically give you 3 things, look for one thing, and we're not going to mention one. That's what that missing variable means. So whichever one is missing, that's the equation you would use. So if I gave you a problem and I didn't mention acceleration or even ask for it, I would use this equation right here. Or if I didn't give you time or ask for time, I would use equation number 5 right there. Okay, so we're going to do a lot of practice in this video, so hopefully this will help. Number 1, a car initially moving at 10 meters per second. Okay, so you've got to make sure you've got your units down. Okay, so meters per second is going to tell you velocity. Okay, so initially moving, so it told you VI is 10 meters per second. Now, on the units, I would practice writing them more and more. The more you write the units down, especially in this little box area, the more you're going to understand what unit goes with what. Okay, once you write meters per second enough times, it starts to stick that velocity is meters per second. So if you struggle with units, the more you write it, the easier it's going to be. Then accelerates at a constant rate of 2 meters per second squared. So I told you acceleration is 2 meters per second squared. And I will not always say accelerates. I can say it just increases at a rate of 2 meters per second squared. But as soon as you see that meters per second squared, okay, that is a dead giveaway. That is acceleration. Okay, so you've got to be able to understand those units, because if you can't pick out what I give you in a problem, it's going to be kind of difficult to organize your information and figure out which equation to use. And then I go for 4 seconds. So that's going to be my time, 4 seconds. Okay. How far did the car travel during this time? So that means I am looking for distance. Okay. So the one they did not mention at all is V final. Okay. So when I go up here to these equations, okay, we're not going to use the one that we're looking for. I'm not going to use this D formula, the missing variable D. Okay. Because one, here's a dead giveaway. If you were looking for distance, do you see a distance in that equation at all? No. So if D is not even in the equation, you wouldn't even be able to use it. So what we're going to do is we're going to actually use this third equation right here, since VF was not mentioned at all. Okay, so that's going to be the D equals VIT plus 1/2 AT squared. Okay, so what we're going to do is we're just going to plug in. So D we don't know. VI is 10. Our time is 4. Plus 1/2 A, okay, that's going to be 2, and time is 4 again, and that is squared. Just be careful right here, is time is the only thing that's squared, so please do not square everything in that group. Okay, so if we did this correctly, we should have a distance of 56 meters, and that would be our answer right there. Okay, number 2, a rock is dropped from a cliff that is 80 meters above the ground, so that's our distance, so 80 meters. Okay, if the rock hits the ground with a velocity of 40 meters per second, what acceleration did it undergo? Hint, if the rock is not moving before it's dropped, what is the initial velocity? So if it's not moving when you're holding on to it, okay, your initial velocity is going to be 0 meters per second. Now, that means my final velocity is going to be 40. And we're looking for what acceleration. So A is your question mark. So that means they did not care about time. So what I'm going to do is I'm going to use the equation for time. So I'm going to come back up here, and we're going to use that equation right there. Okay, so the VF squared equals VI squared plus 2AD. So I'm just going to plug in as we go. So VF squared is 40 squared equals VI squared, so that's 0 squared. You don't have to put that, but I'm just showing you how I'm plugging in. Plus 2 times A, I don't know A, so I'm going to leave it as A. And then my distance is 80. Okay, so we're going to treat this A like X, and we're going to try to get X by itself. So what I'm going to do first, I'm going to simplify it. So 40 squared is 1600 equals, now I'm going to do is I'm going to combine that 2 and that 80. So 2 times 80 is going to give me 160A. Now if you want to get A by itself, okay, divide both sides by 160, and you're going to get an acceleration of 10 meters per second squared. So there's your answer for number 2. Okay, so we're going to go into number 3. Georgia is jogging with a velocity of 4 meters per second when she accelerates at a rate of 2 meters per second squared for 3 seconds. How fast is she going now? Okay, so the biggest confusion that we're seeing is when do you know when is it final velocity and when is it initial velocity? Okay, so you just got to make sure you're reading the problem very carefully. If Georgia is jogging with a velocity of 4 meters per second when she accelerates at a rate, so that means she's accelerating from 4 meters per second, that means my initial is 4 meters per second. Because if you look at the question, it says, how fast is she running now? So that means my question mark is, what is her final velocity? Her acceleration is going to be 2, and her time is 3. So that means they did not care about D. So what you're going to do is you're going to use that first equation. Okay, so the VF equals VI plus AT. Okay, so VF was 4. I'm sorry, we don't know VF. My apologies on that. So we don't know VF. VI is 4 plus A, which is 2, and my time is 3. So that's just going to be some basic math. So my V final is going to be 10 meters per second. Okay, number 4, a train takes 10 seconds, so I got time is 10 seconds, to speed up to, so there's the key thing there, speeds up to 15 meters per second. So that means my final is 15 meters per second at a rate of 1 meters per second squared. So this is what I mean by I'm not always going to say acceleration. I just said rate. Okay, but if you see that unit, meters per second squared, that is acceleration. So 1 meters per second squared. How far did it travel while it did this? So that means you're looking for distance. So that means it did not care about V initial at all. So we're going to use equation number 4. So the D equals VFT minus 1/2 AT squared. Okay, so distance, I don't know. I'm going to leave it as D. Okay, VF is going to be 15. Time is 10. Minus 1/2. A is going to be 1. And T is going to be 10 squared. Okay, so if you do a little cleanup, okay, that's basically 150 minus 50. So that's going to give you a distance of 100 meters. Okay, number 5, a bicyclist is traveling at 25 meters per second when he begins to decelerate. So that means he's starting to slow down. So that means this 25 right here was my initial velocity. So 25 meters per second. Decelerates at negative 4 meters per second squared, so that is my acceleration. It is okay to be negative because that means it is slowing down. It's going against your velocity. So basically what that means is, let's just say the bicyclist is going to the right with a positive velocity. That means acceleration is going to be going to the left because it's going against him. So therefore it can be negative. How fast is he traveling after 5 seconds? So time is 5 seconds. I'm looking for VF, so there's your question mark. So they did not mention distance at all. So I'm going to use that first equation. So VF equals VI plus AT. Okay, so VF I don't know. Okay, VI is 25 plus A, which is negative 4, times T. Okay, so VF is going to be 5 meters per second. So this is what I mean by it is okay to have a negative velocity, because it needs to be negative right here. Because if you're slowing down, you're starting at a velocity of 25 meters per second. That means your final velocity better be smaller than what you started with. Okay, so if we didn't have that negative, it would be bigger. So you just got to be careful with that. Number 6, a bike accelerates uniformly. Uniformly just means at a constant rate. Okay, so it just means your acceleration is not changing. From rest. There's a key take right there. So from rest means your initial velocity is 0. To a speed of 7.10 meters per second. So meters per second, that's a dead giveaway, that's velocity. So that means your V final is 7.10 meters per second. Over a distance of 35.4 meters, so distance is 35.4. Okay, determine the acceleration, so you're looking for A. That means they did not care about time at all. So we're going to use equation number 5. So that's going to be the VF squared equals VI squared plus 2AD. Okay, so VF squared, so 7.10 squared equals VI squared. Okay, 0. That's going to be easy. Plus 2 times A, which we don't know, and D is 35.4. Okay, so what I did is I'm going to clean this up. So 7.10 squared is 50.41 equals, I'm going to take that 2 times the 35.4, that's 70.8, and then A. So treat that A like X, so divide both sides by 70.8, and you're going to get an acceleration of 0.71 meters per second squared. It is okay to get a decimal. Not everything has to be a nice bigger number, okay, because It's just not that way. 7, a ball is dropped off a cliff and takes 5.8 seconds to hit the ground. So time is 5.8 seconds. How high is the cliff? So that means you're looking for the distance. Hint, acceleration due to gravity is negative 9.8 meters per second squared. So A is negative 9.8 meters per second squared because it's going down. And if the ball is not moving before it's dropped, what is the initial velocity? So whenever we're dropping something, it's not moving at first. So initial is going to be 0. That means we did not care about V final. Okay, so we're going to use equation number 3. So D equals VIT plus 1/2 AT squared. So we're going to plug in. So D we don't know. VI is 0. Okay, so we're just going to take off that whole thing because T doesn't matter. Plus 1/2 A, which is negative 9.8, and time is 5.8, and time is squared. Okay, so you're going to get a distance of negative 164.84 meters. Now, the reason why that is negative is because you were falling. When you're at the top of a cliff, that means your technical position would be 0. So if you're falling, that would be a negative displacement from where you were. Number 8, a rocket is already moving when it accelerates for 30 seconds, so there's your time, at a rate of 15 meters per second squared, so there's your acceleration, so 15 meters per second squared, up to a final velocity of 900 meters per second, so we know VF. What is the rocket's displacement during the time interval? That means we're looking for distance. That means we did not care about VI. Okay, so we're going to use equation number 4, so D equals VFT minus 1/2 AT squared. So D we don't know. So VF is going to be 900. Time is 30. Minus 1/2. A is 15. Time is 30. And time is squared. Okay, so you're going to get a bigger number on here. So you're going to get a distance of 20,250 meters, which should make sense. You have a rocket moving fast, and it's moving at 900 meters per second. Okay, so that's going to create a big number. Number 9, how long will it take a running horse to travel 45 meters? So there's your distance, so 45 meters, and attain a speed of 7 meters per second from rest. So V final is 7. VI is 0 since you started from rest. How long will it take? That means you're looking for T. That means we did not care about acceleration, so we're going to use equation number 2. So D equals VI plus VF over 2 times T. Okay, so I know D is 45. VI is 0 plus VF is 7 all over 2 times T. Okay, so what you could do here is you can go ahead and solve for this right here, whatever 7.2 is. So that's basically 45 equals, so 7 divided by 2 would be 3.5 T. So divide both sides by 3.5, and you should get a time of 12.86 seconds. Okay, number 10. In Indy 500 race cars, velocity increases from 0 meters per second. Okay, so there's your initial. To 27 meters per second, so there's your final. And 1.7 seconds, so 1.7 seconds is your time. How far does it travel? So that means you're looking for D. And we did not care about acceleration. Okay, so we're going to use equation number 2 again. So D equals VI plus VF all over 2 times T. Okay, so D we don't know. VI is going to be 0 plus VF was 27 divided by 2, and then that multiplies by 1.7. Okay, so do all that. Take your 27 divided by 2 and multiply it by 1.7, and you should get a distance of 22.95 meters. Number 11, it was once recorded that a Jaguar left skid marks that were 290 meters in length. So there's your distance. Assuming that the Jaguar skidded to a stop. So that's another key thing right there is when we say from rest, like starting from rest, that means your initial velocity is 0. If we talk about coming to a stop, that means your final velocity is 0 now. With a constant acceleration of negative 3.90 meters per second squared, so I gave you A. Determine the speed of the Jaguar before it began to skid. So we're actually looking for initial velocity, so we don't care about time. Okay, so we're going to use equation number 5. So VF squared equals VI squared plus 2AD. Okay, so VF is 0 squared. It's just going to be 0. VI squared, we don't know, so we're going to leave it as VI squared plus 2. A would be negative 3.90. Distance is 290. Okay, so what I'm going to do is I'm going to solve for this right here, and then I'm going to move it over to the other side because I need to start getting VI by itself. Okay, so when you multiply that, you're going to get a negative, but when you bring that over, okay, it's going to become positive, so 2262 is the answer, equals VI squared. So again, all I did was just solve for this right here, and I moved it over to the left side, and once you do that, make sure you change your signs. Now, I've got to get rid of this squared, so I'm going to square root both sides. So that gets rid of it over here. So the square root of 2262 is going to give me an initial velocity of 47.56 meters per second. Number 12, a car traveling at high speed slows down. So there's another thing, slows down to 30 meters per second. So your final velocity is 30 meters per second. At a rate of negative 2 meters per second squared, there's your A. Over a time of 6 seconds, so there's your time. How far does it go during that time? So you're looking for displacement or distance. So that means we did not care about VI. Okay, so what we're going to do is use equation 4. So D equals VFT minus 1/2 AT squared. So D, we're going to leave it as D. VF is going to be 30 times your time, which is 6, minus 1/2. A is going to be negative 2. And then T is going to be 6, and that's squared. Okay, so once you clean that up, I'm going to clean it up a little bit. So that's 180 plus 36. So the reason why I did that is because this can kind of create a little confusion right here. So you should have gotten 36. So 180 plus 36 gives you 216 meters. All right, a couple more and we're done. An engineer is designing the runway for an airport. Of the planes that will use the airport, the lowest acceleration rate is likely to be 3 meters per second squared. So there's your A. The takeoff speed for this plane will be 65 meters per second, assuming the minimum acceleration was the minimum allowed length. Okay, when you're on an airport freeway, okay, 65 meters per second is not your initial velocity. You're sitting there, and then you start taking off. So you need to have a final velocity of 65 meters per second in order to get off that runway. So your final velocity is 65 meters per second. Your initial velocity is going to be 0. Okay, assuming this is minimum acceleration, what is the minimum allowed length? So you're looking for how long does this runway have to be in order to make it? Okay, so that means we did not care about time at all. So we're going to use that fifth equation. So VF squared equals VI squared plus 2AD. So VF is 65 squared equals VI squared. Okay, so that's going to be 0 plus 2 times A, okay, which is going to be 3. And then your distance, we don't know. We're going to leave it as D. So D equals 704.17 meters. So that's how long the runway has to be. Last one, a leopard running at a high speed slows down to 5 meters per second. So that means that is your final. Over a 1.5 second time interval, so there's your time. At a rate of negative 8 meters per second squared. So that's your acceleration. Again, it's okay to be negative because they're slowing down. How far does the leopard move while it's happening? So you're looking for displacement or distance. So that means we did not care about V initial at all. So we're going to use that fourth equation, D equals VFT minus 1/2 AT squared. So D, we don't know. VF is going to be 5. Time is 1.5 minus 1/2 times negative 8, because that's your acceleration, times T, which is 1.5 still, and that's squared. Okay, so solve that out, and you should get a distance of 16.5 meters. So again, the key thing here is, one, you got to make sure you know what your units are. If we talk about meters per second, that's velocity. If we talk about seconds, that should be a dead giveaway at the time. The big thing you got to know is you got to know acceleration is going to be your meters per second squared. And if I just mentioned distance, you're going to look for things like meters or kilometers. Okay, so if you don't know those units, it's going to be very difficult in order to fill out this box in order to answer for what you're looking for. And again, you're always using the equation for the one they don't care about. Not the one you're looking for, it's the one they don't care about. All right, so hopefully that helped.